All right, so example one, we're going to find the standard form of a quadratic function for the following function g of x, and then we're going to sketch the graph. All right, so the process of completing the square can be a little tricky, but there's a general process you always follow, and we'll see that with this function, and I'll walk you step by step through this process. So I'm going to write down the function first. And the first step is to factor the leading coefficient, which is 2, the number in front. And so the interesting thing about how we're going to factor this is that we're only going to factor it out of the first two terms. Only the first two terms you factor the leading coefficient. So let's do that. Kind of strange. You may be used to factoring just out of all the terms. So realize we can just factor out of 2 of the terms. So we factor the 2 out and we're left with x squared minus 6x. And then we still have plus 19 because we did not factor the 2 out of the 19. And now at this point, we want to do the completing the square step. And to do that, we want to leave a little bit of space inside this parenthesis here. So we're going to do that now. So x squared minus 6x, and then we're going to leave some space, and then we'll put the plus 19 over here. So nothing really changed here at this moment, but now we're going to do the completing the square step, and that all comes down to the x term. So we look at the coefficient in front of the x, which is negative 6, and we're going to write that down over here. And what we do with the negative 6 is we divide it by 2, and then we square it. So divide 2, then square it, and figure out what that equals. So negative 6 divided by 2 is negative 3, and we still need to square it. That's equal to 9. All right, so now what we determined is we need plus 9 to complete the square. So now this will allow us to factor very nicely. And then, but we can't just add 9 to the function. That changes the entire function. So to keep the balance, we also need to subtract 9. So plus 9 minus 9, we still have the same function. It's still equivalent because there's nothing really changed. Essentially, we just added 0 when you add 9 and subtract 9. But this negative 9 is just to keep the balance, to keep the function equal. But we don't actually need it for completing the square in terms of being able to factor. So we want to get this negative 9 outside the parentheses. So that's where we distribute the 2 just to the negative 9, just to the part that we don't need inside the parentheses. So we have 2 x squared minus 6x plus 9. Now that's just the portion we need for completing the square. Now we're going to distribute the 2 to the negative 9. And that will give us, and I'll just write it out here, plus 2 times negative 9. And then we still have plus 19. So we'll write that down over here. Now, at this point, we want to factor this right here. And by completing the square appropriately, this should factor very nicely. 2 x minus, and then half of this value squared. Half of negative 6 is negative 3, and that's what we'll factor to. Just to check your work, you could, and we'll do that really quick. So x minus 3 squared is equal to x minus 3 times x minus 3. This is equal, and then you'll notice this will equal x squared minus 3x minus 3x plus 9, which is x squared minus 6x plus 9. There we go, we've checked. It truly does equal. So that's what's really nice about completing the square. Using this process here, we have the ability to factor really nicely. And then lastly, we just need to simplify what's over here. So that's 2 times negative 9 is negative 18, plus 19 is 1. So plus 1. So this just simplifies to plus 1. And there we go. We have completed the square, and we're in the standard form for a quadratic function. And what's really nice about this is we have the ability to graph the function really easily when we are in this form. And to graph this, I'm going to show you how to do this by hand. But I'm not really too concerned about you being able to graph a function. That's why I'm allowing you to use Desmos. And we'll go over that in a little bit. At least you should check what I'm doing here. Okay, so here's your XY plane. And -3 and 1 tells us where our vertex is located. And so that's, notice it's usually -h, so 3 is actually h. It's not -3, it's +3. So our vertex is actually located at 1, 2, 3, and then up 1. There's our vertex. And then at this point, we would want to determine if it's pointing upwards, the graph is pointing upwards, the parabola, or pointing down. And since our leading coefficient is positive, our a value is greater than 0, we know that it's pointing upwards. And now in terms of the details of this graph, I mean in terms of how wide it is, realize that a value, as the value gets larger and larger, the graph gets skinnier and skinnier. So it's actually going to be kind of skinny. Not going to be perfectly to scale, but realize since this is larger than 1, it gets a little bit skinnier since the a values are larger than 1. So let's go ahead and pull up Desmos really quickly. And let's graph this function. So our function was 2x squared minus 12x plus 19. And there we go. Yeah, so we're located at 3, 1 for our vertex, and it's pointing upwards. So that looks kind of similar to what I graphed before. And you may be concerned a little bit about if, let's see here, how do I add a function? Oh, there we go. Okay, so you may be a little concerned about, okay, well, how about our standard form, the result we had? Is that really the correct result? Is it the same function? So I'm going to go ahead and graph it. I remember what it was. It was 2x minus 3. And then we square that plus 1. Remember that's what we ended up getting. So notice it just graphed over itself. So if I delete this one right here, there we go. It went right on top of the other graph. So yeah, they're located in the same location. All right, so let me know if you have any concerns. I'll be more than happy to help.